Alright, so my name is Justin Collins. I work at Twitter. I'm not going to be talking about stuff at Twitter. You can ask me later if you're interested. We are hiring though. I'm going to be talking about static analysis. My goal for this was to get you excited about going and building your own static analysis tools. I don't know if that will happen, but something between getting you excited to use them and getting you excited to build them. That's kind of my goal. And to provide some context, maybe, go forward. So I'm the primary author of a static analysis tool for Ruby on Rails. It's called Brakeman. How many people are familiar with Brakeman? Okay, cool. How many people were in the previous talk? This is going to be nothing like the previous talk. I have way more cat pictures in my presentation. So Brakeman was released about 3.5 years ago. Been working on it almost 4 years, which sounds insane when I say it. It's open source. There's been a whole bunch of contributors, a bunch of releases. We just passed 500,000 downloads of the gem, which I don't believe this number. Some people probably download it 1 million times, and other people have their private gem repos or build it themselves. So who knows what the actual number is? But the point is, a lot of people are using it. And I'd like to share kind of what I've learned in building it and using it. This is my definition of static analysis. Some people disagree. This is my definition. It's basically any information that you can get about a program without actually running the program. So that's really broad. And some people have a narrower definition, but this is the one we're going with. Just need to clarify. All right, just because static analysis and dynamic analysis, they sound like opposites, that doesn't mean they fight and are in conflict. You can have opposites, you can use both, they can work together. You should use both, right? If anyone ever tells you, oh, don't use static analysis because it doesn't do this and that, or if they say don't use dynamic analysis, it doesn't do this and that, you can be like, what are you talking about? I use both, and they're both awesome. And then don't buy whatever they're selling. So first I want to talk about the ways static analysis can make our lives better. And this isn't really limited to dynamic languages, but some people think you can't do static analysis on dynamic languages. You can. I built a tool to do it, so you can. So the first thing it does is it allows you to find what you want better, right? So grep, again, some people may disagree. I believe grep is a static analysis tool because you're determining things about the program without running it, right? But we can do better than grep. Grep's cool for some things, but we can do better. I'll talk about it later. So this is kind of the first thing. You can find features of your program that you really care about, and you can make it as specific as you want, and that's a power that static analysis gives you. Another nice thing about static analysis, I love Law and Order Criminal Intent. I love this guy. It's really useful if you're dropped into a code base and you have no idea what's going on. If you can run a static analysis tool, of course I'm biased towards Brakeman, that's all I really work on. So if you're dropped into a Ruby on Rails app, you run Brakeman, you get an idea. It's not going to tell you everything, but it gives you an idea of what's going on. For example, if you run it and you get something like this, and it says, okay, you have 6 warnings, and 3 of them are high confidence, high priority. You're like, okay, it doesn't look too bad. Now, I might be missing a whole bunch of stuff, who knows, but you get an idea. If you're dropped into an app, and you run it, and you're getting over 1,000 security warnings, you kind of have an idea, oh man, I'm not sure what I'm dealing with here. There's probably some core security thing that the developers are missing, right? Maybe they don't know they're supposed to escape output, or who knows. But there's something missing, they're doing something, and it's going to point you in the right direction. by the way, these errors are actually divide by 0. So Brakeman has a nice feature where he'll find divide by 0 for you in the form of raising an exception. So, you know, I mean, it just gives you an idea of where you're going. So that's really nice. But this is the biggest thing. I think if you take one thing away from this, it's realizing that using static analysis in your development workflow, it's going to catch things sooner, right? And it's good to catch things before the bad guys do, right? That's pretty good. It's even better to catch issues before you deploy the code, right? And it's pretty well known, I think, in the security community and definitely in software development, that the sooner you can fix something, the cheaper it is, right? In security, cheaper might mean I didn't expose millions of users to a vulnerability, right? So the faster we can find these vulnerabilities, the better. It just makes sense, right? So this is you know, I'm putting the good stuff up front here. Before you fall asleep, I'm just giving it to you right here. This is really why we want to use static analysis, all right? We can run it, you know, when we deploy the code, maybe we block deploys, maybe we run it as part of tests. Maybe you're just doing a code review, run some static analysis. We can run it as code's getting committed. That's a pretty good place to do it. You could run it as your code is being saved. So like you're typing along, you hit save. There's a whole bunch of tools that basically do file system monitoring, and they will run whatever you want. Like it will monitor a set of files, and when they change, it will run something. So run static analysis, right? If you want to get really crazy, I mean, there are static analysis tools. I heard that while you're typing away in an IDE, I assume, it'll be like, whoa, what are you doing, buddy? Right? Like you haven't even saved your code yet, and it's telling you, hey, there might be a problem here. That's pretty awesome. I mean, this is the power of static analysis. This is the advantage, not of using it over other things, but of using it, period. Blank slide. So I came up with this, I'm very proud. Yeah, right? Don't spend your time fixing vulnerabilities, prevent them, right? And we know that's cheaper because if someone is writing code and they introduce a bug of any kind, and then 6 months later they have to fix it, or a year later, or 6 years later, and the person who wrote it isn't even there anymore, we know that's more expensive. It has to be, because someone has to figure out what's going on and how to fix it. And if it's a security vulnerability, maybe your users have been, or your company has been exposed for that long. It's crazy. So this is the mantra. This is my cat. You can follow him on Twitter. If you want to like write that down real quick or whatever, it's cool. He'll be at the end too. It's just pictures of him, that's it. All right, so now we're shifting gears. Let's talk a little bit about statically typed languages versus dynamically typed languages. This is my definition. I think it's pretty good. If you're wondering what like authority I have to make definitions, none at all. So here's a great way to think about it, I think. And some people on Wikipedia agree with me. When you look at when is the type of an expression known, right? Is it an int, is it a string, is it a whatever object? When is it known? If it's known at compile time and you're compiling something, it's statically typed, right? You know the type when you're doing the compilation process. If it's at runtime, then it's dynamically typed, right? I mean, you guys probably realize this. I just want to be clear so we're all on the same page. So the problem you might realize is that I said static analysis is what we can figure out without running the program. Yet here we were just saying we don't even know the types of expressions until we run the program. So, you know, maybe this was a bad idea. But it's not too terrible. We can do a lot of stuff still. There are some advantages, actually, with dynamic languages. in static analysis. For example, your code doesn't have to compile. If you have an application, and you're like, I'm going to run static analysis on it, and then there's like a typo in a file, if it's a statically typed compiled language, a lot of times you can't even do the static analysis, right? You want to be able to compile it down to whatever. We're not talking about that. We're talking about dynamic languages. Doesn't even have to run, you know. I think this is a big advantage because if you're just given, listen, when I started at Twitter, I said I wasn't going to talk about Twitter, but I will. I ran Brakeman, and there's like 3 files that actually have typos in them. Like syntax errors. That's code that's not even being used. You know it's not being used because it doesn't run. It's crazy. So anyways, you can still do static analysis on it. I got these out of order, sorry. Code doesn't have to be complete. So if you're, see, I didn't even know this when I started running Brakeman, but apparently if you're running some big commercial like static analysis tools, you have to be able to compile the code. That means you have to have the right libraries, you have to have the right compiler, you have to have everything, right? Dynamic languages, who cares? You don't care. You don't even need to have the right version of the runtime, doesn't matter. You can still do static analysis. So there's some good things. Static analysis, if you're familiar with what a compiler does, it's like the same thing except for like at the very end, you do something slightly different. And I like to put this up because, you know, sometimes you get like, you know, if you don't understand what's going on, it seems like magic, but it's not, right? So you have your input, which is the program text, right? You do lexical analysis, you get your tokens out, you get an abstract syntax tree, you do some semantic analysis, which is like, oh, this is a call, this is a variable, you know, that kind of thing. And then at this step, this is where it changes. This is compiling, this is static analysis. So sometimes you convert into some intermediate language. You don't always have to though, so that's why there's kind of like this line here. And then if you're a compiler, you do some optimization, and you want to make it smaller, faster, and then you output some compiled code. If you're doing static analysis, then you do your analysis here. So it's just like writing a compiler, except kind of at the end, you're not outputting code, you're going to output some report of findings that you've discovered. Are there any questions about that? When I realized this, I was like, holy cow, it's like the same thing. You know? Maybe I'm the only one amazed. I put this slide in the wrong place. All right. Or did I delete a slide? Wow. This is why you don't edit your slides right before you walk up here. I was going to say, this doesn't make any sense without the slide. I was going to show you some abstract syntax trees. This is from Python. It's a mess. Sorry, I don't know Python. I couldn't make it better. But you can see we want to get the abstract syntax tree of this call to X with the argument 1. So you see you get this thing out. It's like an expression. It's a call. Here's the name of the function. Here's the args, and then some stuff that we're not using. I can't believe I deleted the Ruby version. This is from Eskrima, JavaScript, same kind of thing. This is basically what you're working with. I'm still going to tell this joke though. So in Ruby parser, it outputs these things. They're subclass from arrays, and there's this method S, and it creates a new S expression for your abstract syntax tree. And people are complaining to Ryan Davis, who I owe a lot to because he wrote Ruby parser, and without that there'd be no Brakeman. And they're like, you have this S, this method called S. It screws up my code because I accidentally typed S, right? And so they're like, you need to change this. So this was his fix. He changed the comment from this is just a stupid shortcut to make indentation much cleaner, and he changed it to this is a very important shortcut to make using S expressions much more awesome. That was his fix. And I don't know why I deleted that slide, that's crazy. So tools like Brakeman, maybe tools that you'll write, a lot of them work on the abstract syntax tree. So it's stuff like this. You know, it gives you information about the code, and there are these big nested trees of information. And that's it. Like, that's all they're doing. And you could do more steps. You could convert this to like some intermediate language and then do work on that. Some tools, they have like what they call like symbolic execution and all this stuff, but you don't really need all that to start. You can just do this. You take this, it tells you what the code's doing, and you can do analysis on it. But why is it hard? I mean, it seems like maybe it's hard because people act like it's hard. So is it hard? Yes, it is harder in some ways. I told this to a room full of Ruby developers. I was like, computers don't know anything. And they were like, oh my gosh, you're right, they don't know anything. Right? When you're looking at a piece of code, you understand it. You understand the context, you understand the importance, what it's doing. Computer doesn't know, it's just like doing stuff. So when you're writing a static analysis tool, you're trying to write a program that understands what the program is doing. And for security tools, you want to have that security context in mind. Computers don't know anything, so it makes it hard. I mean, how many programs could you like analyze and be like, oh yeah, this is what it does every single time, right? You always have input. All interesting programs have input. If they have input, you don't know what they're going to do. That makes it hard to do static analysis. They do a lot of stuff, like crazy stuff a lot of times. But the biggest problem is, like the halting problem, which is like, well, you can't actually analyze every program and say what it's going to do. So, that's a problem. So I guess you can all leave now because I told you it's impossible. I didn't actually mean that to say. So when you're talking to some people and they're like, no, first of all, grep is not static analysis, blah, blah, blah. They're kind of thinking in this context, kind of like theoretical results academia, right? For any input X, these are what you want. Like you want to write a paper and be able to say this. For any input X, there's a program Y that does Z. So awesome. Or for any input X, there's no program Y that does Z. Those are like that's how you publish papers, right? This is what we care about. So I'm going to give you some program and maybe we'll figure out some stuff. Right? Do we care that we can perfectly analyze every program? No. We just don't. We just want some results out. And for security tools, it's even less important that we're exactly correct about everything. Right? Because we're not trying to execute the program. We're just trying to find vulnerabilities. Potential vulnerabilities. All right. So enough about that. Here's some examples. These are basically the techniques that underlie Brakeman, and they're kind of what set it apart from a lot of other static analysis tools. And this is what I recommend doing if you're going to be statically analyzing a dynamic language. There are probably totally different techniques for statically typed languages. Anyways, put on your Rails hat, Ruby on Rails hat. Question is, all right, is this dangerous? We want to know. This is redirecting to somewhere. I mean, is it dangerous?
Depends on what somewhere is.
Thank you, Ken. Yes, so what is somewhere? I don't know. Yeah, in case you guys didn't know. Well, this is simple though, right? Because we're redirecting to a query parameter. We know params is bad in Rails. It always is. So obviously, this is really suspect. I mean, it's so easy, right? We could do this with grep. Now what, though? All right, so if I grep for redirect to, I don't know. I mean, I'm lucky if that line is right above it, which would be weird. But now we don't know. So who knows? So one approach here is we say, okay, well, we know params is bad, so we're going to say somewhere is bad. And then we're just going to trace that. And that's basically taint tracking. We're saying, all right, this is a tainted value, it's probably bad, where does it end up? And if it ends up somewhere dangerous, then it's bad. That's not what Brakeman does. You could do it if you wanted, but that's not what Brakeman does. We can do it's simpler, it's easier. So let's talk about basic data flow analysis. here's our code. We're going to keep a table, right? We see, okay, x equals 1, y equals 2, and then z is x plus y. Okay, well, we know what x and y are, so now we know z is 1 plus 2. This is called constant propagation. I had to look up what these things were called after I implemented them. It turns out they have names. So this is kind of like, we can do this though, right? Like, we know what 1 plus 2 is. So then we can do something called constant folding. You don't have to do this, but it's nice. Imagine this, that z is actually an index into an array, and you've stored some suspect stuff in the array. If you can figure this out, it's really cool to be like, hey, I know that you are indexing this value in the array, and I know it's bad. Pretty cool. Very useful. This is a picture of my cat. You didn't... Yeah. This is while I'm trying to work. This is my laptop. I'm trying to work. This is what he does. By the way, I tweeted this a long time ago. I'm saying that so you know that I'm plagiarizing myself. They don't tell you about this when they're like, yeah, working remotely, working from home is awesome. This kind of thing, they never mention this in those articles. They're like, you know, how to work from home. They never talk about how to deal with your cat sitting on your laptop. So here's the thing. This is like the key. This is the second key. The first key was don't fix vulnerabilities, prevent them. This is the second key. Here's what we're gonna do. It's so dumb. You know, I think if I presented this like in an academic setting, they would just laugh at me. We're gonna copy, we know params back2 has been assigned to somewhere. We're just gonna copy it from there to there. And now we're back to it being really obvious. Now, I don't even care where this came from. I don't even need to know this came from anywhere else. For all I care, it's always been written like this. Now all I do, I look for my instances of redirect to, and it's redirecting to a query parameter, probably a bad thing. That's like the key, the whole thing. I know I keep giving you opportunities to leave, but I mean, you can leave now, because I've given you the key. What about like methods though? All right, so we're gonna like call a method and pass this in, and then like we could do this. We just like keep copying stuff. Now like more methods. Yeah, like maybe we won't do that. So if you do local, or what's sometimes called intra-procedural data flow analysis, that's easy. It's useful. If you're in a language like Ruby where you tend to have methods and people are encouraged to write short ones, this is pretty good. Global data flow analysis, or interprocedural, really slow, lots of resources. It's just like, oh man. I'm sure there's ways of doing it better, but man, it's a pain. So, lesson here, you gotta choose your battles. Some things, like, it's just not worth fighting, right? You're not gonna win. So, for frameworks like Rails, this doesn't apply to everything, but for frameworks like Rails, do local data flow analysis everywhere. That's easy. And then, what you really care about in Rails anyway, and this is what Brakeman does, is looking at the data flow from your controllers to your views. Because all the XSS stuff happens in the views, and all the values, not all of them, but a majority of them get set in the controllers. This covers like the majority of the stuff you want to look for. And now you're not having to do this crazy, like, this method called that method, and passing in all this stuff. So, that's a hint. All right, this just drives me nuts. All right, so we're like on board with that. Just gonna copy the values. So here, if something's awesome, somewhere is gonna be query parameter. Otherwise, it's back. Back is like relatively safe. And then we're gonna redirect to somewhere. So obvious problem here. we set somewhere to a query parameter, then we set it to back, and so it looks totally legit. Right? There's a way of dealing with it. It's a huge pain. Again, I'm telling you this in case you're like, I'm going to implement a static analysis tool. I'm just letting you know up front, this is the biggest source of pain in the Brakeman code and my life sometimes, occasionally. This is what we want to do. So it's not linear anymore, or what they call a control flow graph. We have the condition, and then depending on the condition, we're going to execute different code. So then what's the value of X? We don't know. We don't know what A is. So now we're screwed, I guess. So the approach, which it turns out this is like a very common thing to do. This is why you should read literature before you write the code. So we take this, we basically union the values. You say X could be 1 or it could be 2. And if you wanted to express that in Ruby code, maybe you just say, okay, 1 or 2. Now X is 1 or 2, and if one of those values is dangerous, now we know. Again, we're only looking at the actual call site right here. But we can look at the values that it might be, and we say, like, hey, it could be dangerous. But if you're going down this road, let me tell you, it's painful. It's way easier to just be like, well, I'll just assign somewhere in the back, and then, you know, people use conditions, whatever. So again, we're thinking security tools. We're not trying to publish academic papers. So we don't care necessarily about preserving the semantics of the program. We just want to find vulnerabilities, right? So in this case, like, we're calling destroy, and then we're copying it everywhere. So if we ran this program after doing that, it would call destroy like 4 times instead of once, right? But we don't care. We don't care, right? You understand why we don't care? Or am I like, you're like, no man, we care. All right. This is not my cat, but you know, the point is it's close enough for what we're trying to do. This is just part of me trying to convince you that you can go and write a static analysis tool for the stuff you need. Please do it for Django, so I don't have to. All right, next section of the talk. And it looks like I'm getting through this pretty quickly, so you can either leave early or I'll have plenty of time for questions. All right, so lessons that I've learned, kind of things, I don't know, I'd like to share with you, things I think have worked really well with Brakeman. So, Unix philosophy. Trying to grow my beard out a little bit. So have a narrow scope. Like, don't be like, I'm going to analyze any program possible. Brakeman does one thing. It does Rails. That's it. And people are like, man, would you do Sinatra? I'm like, you can try it. I'm not going to support it. Right? So just do one thing. It's going to make your life so much easier. You can always branch out later. Start with one thing. Design your tool for developers. If you're writing a security tool, you should really be designing it for developers. This means documentation, this is defining things, this is giving them pointers to more information. He's looking in the window. Remember, we're trying to catch things before they get deployed into production, before they go into our applications. Who's writing the code? Are you writing the code? Maybe if you're a developer, maybe if you're on the security team, maybe. But it's the developers writing the code. They should get to run the tools. It shouldn't be the domain of like some security expert that's like, I will interpret this for you, right? And it's awesome. People tell me all the time, like, I don't know anything about like Rails security, but I ran Brakeman and I learned stuff. So it's a learning tool, it's a teaching tool. Oh, yeah. And for other people who value their time and don't want to spend hours figuring out your tool, right? I mean, make it easy. This is how you use Brakeman. It does presuppose that you have Ruby installed, but otherwise, you know, you install it, You go to your application and it's one command. No options, no required options, right? You just run it. I think this is what you gotta do, right? Support lots of versions. I think one of the reasons that Brakeman has been successful is because of, you should see my notes, sorry. I think my cat walked across it when I was writing that. This is kind of an accident of when I started writing it. And the fact that a lot of companies are still using legacy versions of Ruby, especially when, 3.5, 4 years ago. But it works, I don't know if it works with Ruby 1.8.6, but it definitely works with 1.8.7 and newer, right? And that's from 2008. Ruby on Rails 2.3, I think it will actually work with 2.0. That was 2009, right? So if you want someone to use your tool, support everything, right? Because otherwise, people are gonna want to use your tool, and they're not gonna be able to. But if they're like, oh man, I have this legacy app from like years ago, can I use your tool? And you're like, yeah, of course you can, they're gonna love you. I assume this is love and not anger. Right. Man, all right, so it sounds obvious, right? Like, everyone hates false positives when they're running a tool. They hate getting false positives. They don't want to be told about stuff that's not really a problem. They only want the stuff that's really a problem. The sad thing is, you're not going to be able to give them that. So try to limit it, right? Some tools, and I'm not even thinking of any tools in particular, I'm just saying in general, you kind of like they just dump everything on you. Anything that could possibly be a problem in your remotest imagination, like, yeah, you should look at this, right? And it's not an approach if you want people to actually use and enjoy using your tool. Because they're going to eventually just burn out on reading these long lists of things and trying to find the stuff that's real. Now, does Brakeman have no false positives? Of course not. It has a ton. Depending on how your application is written, it can have a ton. But, try to limit them, right? By the way, #1 question asked at talks about Brakeman, how do I ignore false positives? Is there a way for me to ignore false positives? And for a long time I was like, no, you should not ignore false positives. You should report them to me because A, I should fix them, and B, it might not be a false positive, it might be a real positive. Positive? Now Brakeman does have the ability to do that because, it just got to the point where, yeah, you need, people need to be able to do that. But the real goal is to limit the false positives, so people trust your tool and want to use it. Don't feel like, oh man, like it gives me like a million things that aren't a problem and one that might be. Oh, wait. You just said to limit false positives, but now you're saying you don't need to be perfect. So these are kind of in conflict, right? You want to only report stuff that's really a problem. But sometimes you just don't know. So you gotta tell people. And if you try to be perfect, it's just not gonna work. I mean, I keep saying this, but it doesn't have to be perfect. You don't have to have a beautiful, perfect tool that gives you like exact answers about things. We're security people, we're looking for security vulnerabilities. Just point us towards them, right? So we talked about abstract syntax trees. Actually, traversing those trees is like ridiculously slow. It will take forever. And this is what Brakeman used to do. And there was an application that we used where I used to work. And it took 20 minutes to run Brakeman on it. And I said, okay, Brakeman can never run for longer than 20 minutes. That's a long time, but that's like the limit. It can't be slower than that. And then I realized this problem. Like, man, I'm like going over these trees over and over again. So what you do is you just index everything. And this is easy in Ruby because everything that you're interested in, almost everything, is going to be a method call. So what Brakeman does, and what I would encourage you to do, is to think about building an index of the stuff that's interesting. So you parse the program, you go through the trees once, you build an index, and then you look everything up in the index. And by index, I just mean like a hash table that you can look stuff up in. Yeah. Oh, so that program, or that application that took 20 minutes to scan, it started taking 5 minutes. And then it got a little bit faster. And then I started thinking and saying, well, if Brakeman takes longer than 5 minutes, it's a problem. Well, man, like 5 minutes is not really that long for a static analysis tool. I can tell you, most open source applications, you scan them, it's like less than 30 seconds. Commercial applications, you know, they tend to have weird stuff going on. So this is, you know, this is something you have to balance, but people want fast tools. If you're trying to run something in continuous integration, if you're trying to run something every time you save a file, it can't take 20 minutes, right? People love it when their tools are fast. It just makes sense. Everyone loves fast stuff. And I love Burnout. That's what this is from. I love that video game. Of course, you can't like totally neglect doing stuff in depth, right? You have to return good results. But is it more important to have a totally complete picture of something, or is it more important to like finish something today, right? So I think you need to lean towards speed. And you know, again, people want things to be fast. This is like kind of a really specific thing, but I made a big mistake in Brakeman. And that is, again, I was thinking about speed. And now all the checks in Brakeman are independent pieces of code. But each check, you know, or what you might call a rule, it can actually produce lots of different kinds of warnings. So now when you go back and you're like, well, what if someone wants to turn off that warning? Well, in Brakeman, and again, this was a big mistake, you have to be like, well, I'm going to turn off that entire check. But now you're turning off probably more than one type of warning. So now you're kind of stuck, and it's annoying. And so don't do that. The other thing is, in Brakeman, each check is like a class, a Ruby class. And that discourages you from writing new classes. Because you're like, oh, I don't want to have like a directory of like 50 Ruby classes to do all this stuff. That was a mistake. Because of this issue. Oh, I want to turn off this thing. I can't. You know, oh, I want to fix this thing. Like, how's it connected to that thing? So, just a piece of advice. If you're going to write rule engine checks, my suggestion, and I started working on this in a new tool, have groups of checks and then individual checks. A single check only produces one type of warning. One, you know, whatever that means. And then that allows you to turn off groups of checks and allows you to turn off one check. And again, the reason I did it was speed. Because remember, I was like going through the trees all the time. I'm like, well, if I can go through the tree and catch this thing and that thing, like, and they're kind of related at the same time, then it's faster. Well, if you're using an index, it's pretty much fast enough to do everything separately. So, learn from my mistake there. This is another thing that I wish I had thought of sooner. If you're running a tool like this, and it's in something like continuous integration, which it should be, that's where I recommend putting it. Put it as a commit check hook, put it in your continuous integration, it should be running all the time. I talked about it a lot in other talks. If you want to go listen to me talk more, it doesn't make sense for you to be sitting there and go, run Brakeman, now run Brakeman, now run, that doesn't make any sense. But if you're going to do that, people have to be able to see like, well, I ran it yesterday and I ran it today. What changed? Did anything change? Are there new warnings? Did I fix some warnings? Like, what's the situation? So if you're going to write a tool like this, you have to implement some way of comparing reports. Someone has to be able to say, okay, I already said it. So to kind of go along with that, Each warning, I think, is really helpful. Generate some kind of unique fingerprint for it. And don't include stuff that you might want to change in the fingerprint. So if a warning has a message attached to it, trust me, someday you will want to change the text of that message, so don't make that your fingerprint. And then another thing, again, these are kind of specific, but I just want to tell you what I learned. Brakeman used to have categories that were strings, and it was like SQL injection, right? Well, what if one day I was like, well, I don't want the I in injection to be capitalized anymore. I want it to be lowercase. And now you're using my report comparison, and now it tells you it's a different warning because I changed the capitalization of the letter. That's a bad idea. So a good idea is to use IDs that describe the vulnerability and use integers. That's what I did. And they never change. So if you get a warning and it's got this ID attached to it, you know where it came from and what it means. All right. Testing. Brakeman didn't have any tests for a year, right? Which tells you I was not on a software development team. It's actually really hard, in my opinion. People might disagree. And if you disagree, please write some tests for Brakeman. But it's very hard when your tool requires consuming an entire application in order for most of the pieces to work, because they all work together on this representation of an entire application. So I didn't put this up here because I didn't believe it. I ran code coverage and it said it had 92% code coverage. I don't even believe that because it sounds too high. But what I do instead, or in addition, I have 281 Rails apps I found on the internet. Together they produce over 14,000 warnings. Every time I make a change in Brakeman, I run it against all these apps. And by the way, you need a way of comparing reports if you're going to do this. And I have a dashboard. It kind of looks like this. I don't label any axes, or anything. And this is not me trying to hide information from you. This is me just being a bad web developer that you can't even read the x-axis. But this is what I use, and someday we'll probably open source. I have to take out stuff and make it prettier, but the idea is to encapsulate all the variations of crazy stuff that people do in their applications into unit tests is really hard. I think this is a good approach to use in addition to unit tests. And basically I run it, I look at this graph, this is how many warnings were found across all the applications, and if it changes, then I get scared. But then I also run an actual comparison between them in case just the number of warnings didn't change, but the warnings themselves did. This is the errors, so if there's errors, if this changes either way, I gotta find out why. This is just how fast it runs, I don't really care about. This is the number of projects being scanned. If this changes, I get worried, unless I've actually added one, right? So I think it's just a good approach to testing. I just got to warn you guys, you probably know this, all right, but people will do weird things. I didn't get a chance to come up with a really good example besides this lady with a cat. I didn't have a chance to come up with a really good code example for this, but trust me, people do really weird things, all right? And your tool is just going to have to deal with that. The good news is, if you have an open source tool like Brakeman is, people will generally tell you, hey, I ran your tool and it didn't work. And then you kind of have to dig in and be like, okay, did you do something weird? And yes, people do weird stuff all the time. All right. So, too long, didn't listen. Here's kind of the key points. And I think I've emphasized them pretty well. So, you want something practical over perfection. Again, we're not trying to publish, papers in academia about this. We want a tool that works, right? So be practical. Simple data flow has awesome results. Sometimes I talk to people who work on other static analysis tools, or people who are, kind of in that world. I'm like, look, Brakeman does nothing special. It doesn't do any cool stuff. It does what I showed you. It copies values. Actually, it does do some cool stuff, but it copies values, and that's like the whole core of the thing. And I would recommend for dynamic languages, take that approach. And again, this is where we want to be. Not fixing vulnerabilities, but preventing them, right? And that's an advantage static analysis has. Because if you want to do dynamic analysis of a web application, you have to have a web server, write a database, you like set it up somewhere. And you can do that, and you could probably even get that working with continuous integration, and you're running your scans. You can do that. And you should, because I think that sounds awesome. But static analysis can get closer to the origin of the problem in time. So hopefully I've convinced you that that's the case. This is my cat. So on Twitter, or almost anywhere on the internet, if you want to stalk me, PresidentBeef. @Breakman is the Twitter handle for Breakman. Breakman.org or breakmanscanner.org will take you to the website if you're interested. And then again, my cat's Twitter handle, right there, only pictures of my cat. That's so that you can follow me and not have to see pictures of my cat if you're not interested. I don't know why you wouldn't be, but that's why the separation. And that's all I have, but I would love to answer questions or talk more about this stuff if you guys have something to ask. If you don't ask, I will use the rest of my time however I see fit. Yes?
What's the name of your cat?
My cat's name is Makoto. He is named after Makoto Nagano from Ninja Warrior, if anyone's a fan. Not because he's black, but because he's kind of like a ninja. I'm talking about my cat being black. Makoto Nagano is Japanese. Other questions? Are there any questions about how to get this integrated into your development process?
Can you talk about that a little bit?
Sure. So I can tell you that when I started at Twitter and my coworker Neil Madishall worked there, he went to each development team of our major Rails apps and said, how do you do code deploys? And then they said, this is how we do our code deploys. And he said, okay, how can I put Breakman in there? And they said, okay, you could put Breakman right here. And then he did that for like 5 or 6 teams. That is not the way I would recommend doing it. It's nice, but for one thing, we had no visibility into that. So I still don't even know if they're like actually using it or not. What we ended up doing, and we've given like several talks about this. So again, if you want to hear me talk more, you can go find it. We built a system that basically, as people are committing code, it scans it. And if it finds something, it emails them and us, saying, hey, I think I just found a new vulnerability in your code. This was the commit that you made. And it sends them an email. I think that's a really good approach. And if your tool's relatively fast, I mean, they're getting those emails like, they push the code up to the, use Git, push it up to the Git repo, and like a couple minutes later they get an email saying like, hey, maybe you want to look at this, it might be a problem here. I think that's a good approach. If you can get it closer to the developers, that's awesome too.
Yeah, does Breakman, if you've got an application, a Rails app that imports or requires a lot of dependencies, does it analyze those as well? And my second question is, can you give me an idea of maybe what are the 1 or 2 patterns that if you were to write a new tool that you would start off that are common, easy to detect?
Yeah, okay, so the first question is, does Breakman scan dependencies? No. Maybe one day, but I mean, it's so slow. It would be just ridiculous. And trying to understand what those dependencies are adding to your application is difficult. So right now, no. The second question is, if you were going to start on building a tool like this, what are easy things to find? Command injection is really easy. because generally you don't want to be shelling out to something and putting almost anything in it unescaped, so that's really easy. Cross-site scripting is actually kind of easy. I didn't talk about it, but a really good approach, like in Ruby, for example, all of the templating languages compile to Ruby. So you compile the template to Ruby, and now you just have to analyze Ruby again. It's hard to get that right, but it's easy to get started on that. Hey, there's unescaped output right here. It's pretty easy. And then SQL injection is also relatively easy because most frameworks are going to have a particular good pattern, and all of the other patterns are bad. So looking for, okay, this is some call to the database, what's getting passed in how, that typically is pretty easy as well. Any other questions? Yes? Sorry, I couldn't quite hear that.
You mentioned earlier that you use gifts in the number of warnings. You send people mail, you send them only, oh, I got more warnings or less warnings.
Yeah, so the actual email only lists the new warnings that were found, and it kind of has like just a little bit of information and then links to an internal page that has the full information about it. So yeah, it's like, these are the things that we think you just introduced. Again, of the tool, acceptance of the tool. So it's one of those things, your results may vary, but after we implemented this, we didn't get a lot of people introducing vulnerabilities. And generally, if someone does get an email, again, we get copied on it, and what I do, I email them right away. And I tell them either, I think this is a real problem, or, hey, like, you know, I see what's going on here, and, you know, this probably isn't an actual vulnerability. So even though it's an automated tool, it happens so rarely now that I just personally respond as well to the same email thread. And people seem cool with that. Yes?
Do you know anything about static analysis tools for other dynamic languages that you could share? If they even exist?
Yeah, so, you know, part of my motivation of doing this talk is like, they don't exist. Static analysis tools for other dynamic languages, there's not really much out there. There's not even much out there for Rails, and I've already shown that you can do it. There just really isn't much out there. And I think there needs to be. Like, every time I have to look at a Django app, I'm like, I wish I had Brakeman for Django. I see other people saying, hey, does anybody know a tool like Brakeman for X, whatever X is? So there's a high demand for it. So if you want to build it, people will use it for sure. Other questions? I have stickers that look like this, but a limited supply. So if you want one, please come talk to me. Thank you.